plug in the 49.4 degrees into this equation here, and that'll be my prediction. So my prediction equation was 1,425 minus 1987 times 49.4. And that'll be the prediction. So let's see what we get when I do that. That gives me roughly 443.4. So the residual will be the difference between these. So I'm looking at a residual that's 76.6. That's how much error that we have. That would be the calculating part. The interpretation is basically, okay, was my prediction too high or too low? Which one was it? Too low, right. So my prediction was too low. All right, so that was the residual part. That part's usually not too bad, hopefully. The tougher part was when we started interpreting things. So the first thing they wanted us to do was interpret the slope for the regression line. Well, before we can interpret it, we need to know what is the slope. So in that equation that they gave us, which part was the slope? It would be the 1425 as the negative 19.87. Which one's the slope? Yeah, I mean, we're going to keep the sign with it. But so our slope is equal to negative 19.87. Now let's think about what that means. Well, remember the slope is based on every time x goes up by 1, this is what y is doing. So my x is on this one more the temperatures. So according to this, when the temperature goes up a degree, what happens to the gas consumption? Well, according to this, the gas consumption goes down 19.87, and they measured it in cubic feet. So when the temperature goes up 1 degree, the gas consumption decreases, so it's negative 19.87 cubic feet. All right, so that's usually the tough one to figure out the slope. But again, it's every time x goes up by 1, what's y doing? All right, then the y-intercept. Well, they want to know, first of all, does the y-intercept have any meaning? And if it does have meaning, then what's it actually saying? So the y-intercept is when the x value is equal to 0. So on this one, that's when the average temperature is equal to 0. According to the equation, this is how much I would use in terms of the gas consumption. So let's see if that would make sense. Well, first of all, is it possible to have the temperature of 0 degrees? Yeah, yes, so that's been 0 degrees around here before, so that's possible. All right, so the question of does it have meaning? Yeah, this one would have meaning, because I can have a situation where the temperature could be 0. So when the temperature is 0, according to my equation, I used 1,425 cubic feet of gas. So that one actually did make sense. We had one the other day where it did not make sense. Did the slope being negative make sense? In other words, as the temperature goes up, did it make sense that we'd use less gas? Yeah, because the warmer it is, the less you're going to have to use your heater, right? So as the temperature goes up, you don't have to turn on the heaters. So that one makes sense as well. So from Friday, those are kind of the three main ideas again. Being able to plug in a value, make a prediction, check that prediction by looking at the residual, and then being able to look at the slope and the y-intercept and see what they had in terms of meaning. So today I'm going to have you practice that with an exit ticket, and then we said we'll move on and look at see how we actually get those regression equations, and that'll be the next section. But to begin with, this is going to be an exit ticket that I'd like you to complete. So again, this is to give me an idea of what you're catching on to, what you're not catching on to. So you're going to use that data there. Now with that data, and almost every time that you're given a table, usually the first row is going to be your X and the second row is going to be your Y. Okay, and that's the case here. Temperature will be your X, quantity is going to be your Y. So keep that in mind as you start answering those questions. You're going to make the scatter plot. When you find the R value, you can do that on the calculator. Just in case you need a reminder of how to do that, I can help you with that. And then on the back, there's some questions related to the regression equation. All right, so this exit ticket is obviously a little longer than some of the other ones we've had, so we'll take a little bit of time. But once you finish, you just put it in the box up here.